Hello, everybody. Welcome back. Welcome to week 2 of 353. Here's where we are. So we've had a week, and partially I'm saying this because I'm recording this before the semester starts again. And okay, we've had. Hopefully, I've seen many to most of you in Cecil on Friday. If not, we will be there next Friday. The TAs and myself in 9700. If for some reason you haven't watched these first couple weeks of lecture, those videos are there as normal YouTube videos now. And well, let's go. Right, exercise 1 is due this Friday, so get on top of that. I was talking at the end of last week about NumPy and pandas. Well, I guess I talked about NumPy as much as I'm going to explicitly say. Let's get to pandas. A little bit more, interesting example here, where I've created this data frame of 3 Canadian cities. I've used the name of the city as the index, so each row is sort of identified by its name, and then I have these 2 data columns, population and area. I have that over here in this Jupyter notebook, along with whatever else I was doing last week. Okay, there we go. So again, totally reasonable. If the index confuses you, yeah, that seems totally normal. Actually, maybe I'll do this. So this thing you can do called reset index, which I will mention in a few slides, is basically like either promote or demote. I'm not sure which way this is, but sort of move the index column over to be a normal data column, which is sometimes what you want to do, right? You might want the thing to be the index for a while because you want to identify rows this way, or you want to join things on that, and you want to move it back to be a normal data row. So I feel like name is a better name for that column. Anyway, but I have this data frame. These numbers are, well, old if they were real at the time. So now, once again, you do these sort of whole column at a time operations almost all the time. There's a bunch of pandas operations. You can do like a whole bunch of, handy, useful methods on every series, which is, of course, what we call a column in this world. Like there are methods called div for divide, but you can also, and probably should, because you're not a crazy person, just use the divide symbol. Okay, so like the correlation with another series, great. That thing that's, I don't know, is this R? Oh, I guess right. Which correlation do you want? You have a choice. But yeah, the R value from the stats class, yeah, there's a built-in for that. Cool. I have here used rank. So just if I was going to sort these, what position would they be in? And so if I sorted by decreasing population, this one would go first. Then that's handy. I said at the end of last week, like if this line of code doesn't tickle you, I don't think we're on the same page here. Population density is population divided by area. It's just what it is, and you can say it in this beautifully compact way and have it done on 1,000,000 rows in a data set, no problem. The other thing I've done here, again, I wouldn't usually do this way, but if you do have some crazy Python logic, or you want to import the Python library that does some calculation that you don't want to implement yourself, you can vectorize it and then apply it to a column. You can also use .apply, that is call this Python function on each thing. Maybe actually, maybe in the notebook I'll do it this way. So define my function, and once again, if you're defining functions, I think you should consider moving away from a Jupyter notebook to a .py file. And then So what I did in the slides is the np.vectorize. So this is also going to be a slow thing to do, relatively speaking, because this implies call the Python function many, many times, and that isn't as fast as doing the operation with straight pandas or NumPy operations, but it'll get you there. If you really have to, if you have another way, that'll work. So I think point being, you get a lot of power with pandas to do a whole lot of stuff with very little code. You know, I think I said last week, like you're writing almost no loops this semester. I would suspect you almost will never use an if statement. There's a lot of like from a programming perspective, very simple code, right? You're not writing algorithms, you're calling algorithms just based on what you need to get done. And that's great. Okay, so I have that. Like I said, the reset index is move the index column over to be a data column, which sometimes you might want to do. No idea what. See, again, I think what's happened here is I've run these things in some completely unknown order. I've no idea how my data got from here to there. This is the danger of the notebook. Okay, let's just do that. Nuke from orbit, start over. Yeah, okay, there we go. This is what I expected. Name has been moved over to be a data column. So, and I guess the reason I might want to do that is I can't do this, right? I can't, oh, I can. Once again, I'm running things out of order. My annoyance with Jupyter Notebooks is becoming hatred. Okay, I can't do this because that's the index column, not a data column. If I want it to be a data column, if I need it to be a data column, I can do that. Move it over. And then if I want to change the the index to be that because I do want to join that way or something, I can. That was a long way to go for that. So, super handy tool to have in your toolbox. Again, even if you're not going to be a data scientist and you just want to be a programmer who can kind of do useful things sometimes, I think Pandas is a really useful thing to have hanging around. Okay, where we're heading now is sort of here. Again, figuring out the question, this is another course, or it's so situationally dependent, there's nothing I can say here. I can talk about sort of getting the data from where it sits into your code, and for that, like, I mean, into Pandas, right? To get it into a Pandas data frame. Of course, there's many ways, but of course, we don't use all of those ways all the time. Probably, and like what you're going to do for me mostly this semester is read files, because it's really easy for me to distribute files to you. Here's a zip and you start exercise 1. You can just do that. Like, I hope you have read a file at some point in your programming career. You could do that and turn that into a data frame in whatever way you construct a data frame. I guess I've done it here, right? Like, if you could in any possible way build this, then you can get a data frame out of it, but that's annoying. I would like somebody else to do the work for me. And of course, there's a relatively small number of pretty common file formats, and well, Pandas knows how to read them because people need that. We'll come back to some examples. Maybe you have the data in a database, and like, this is totally a reasonable thing, right? Like, a database is a really good place to put data. That's its whole job. SQL's been around since like the 1970s. We like it, it's useful, but it's also another course. To having a whole data science course and not really talking about databases is weird, but just go take the database course. Do it with that too. It's fine. If what you have to do is like acquire data, maybe it's a web service. And if you haven't used a web service before, it's basically stuff on the web, aka stuff you can make an HTTP request for, if you can figure out where to get it, and you get back some kind of machine readable thing. Basically some file format like I'm about to talk about. So it's get the thing off the web and then read it as if it was just a file. Or maybe just download the file and then read the file. What you don't want to do is call an API any more times than are absolutely necessary. And I've seen students do this where, you know, like their code hits the API 10 times at the start of every run for their project, and then they're confused about why their code doesn't work anymore, and it's you got blocked for being abusive because you ran your code 50 times because you were trying to figure out something else. You know, 10 lines down or whatever. This is the reason for this kind of thing, right? You do the API hitting in this program, you run it, you write files. And then you can read files off your disk 1,000 times. Nobody cares. Separate these things, store them as files in some way. Again, probably what you're going to get back is a JSON file, which I'll talk about in a second. Maybe you're going to have an outage, or you're going to get blocked, or your IP address is going to get blocked, or like the campus network range is going to get blocked because the person beside you in CSLL is being a jerk. Who knows? Keep this kind of thing in mind. So I probably should find a better example, but we all kind of know this, right? Like the Twitter API is now expensive, but it still exists. So I'm just going to go with my example, and they've broken my friggin' link. I hate you all so much. Well, never mind. What you will get back, if you can figure out how to smack it around hard enough, is for a user, you can request their most recent N tweets. N is 1,000 or something, or maybe it depends on your pricing tier. What you get back is a JSON blob. So that's a text-based format representing this data structure. It's a list of objects or dictionaries or maps or however you want to think of it with this kind of thing, right? It created at date, time, and the text and the who it was, and was it a response to something, and you know, did it get flagged as inappropriate? Like there's all of these fields. You can of course ignore ones you don't care about, but you get this and you have to then do something with it. Maybe what you have is not an API, but it's online as a web page, as like HTML or whatever. And again, I see students do this for their project. It's like, if you have to scrape HTML and you have to like read HTML that's meant for a human and then try to get data out of it, you're having a bad day, right? Like this is not awesome. This is a really annoying work. Maybe your thing is going to get blocked because you trigger some, you know, bot attack thing on their website. Who knows? Or maybe they just update their HTML because that's allowed. That's a legal thing for somebody to do, especially if they don't want you to do this. But you know, you can imagine, yeah, I know what a Wikipedia profile, a freaking profile is. I don't want that. I don't know what kind of, like, there's better ways to get data out of Wikipedia, but these will be websites, these will be web pages with stuff in it, sure. You know, there's going to be a table here somewhere, right? If I scroll. So you might want to, and I mean, you can probably copy and paste this table, but maybe you want to download it and you would go and look for this table and then try to extract, you know, each row, each column, something, something, something. That's going to be super annoying, especially because the HTML that is served to web browsers is not as beautiful as a sort of machine expects usually. Web browsers deal with a lot of broken, horrible crap. Beautiful Soup is an HTML parser that deals with broken, horrible crap. That's basically its whole job. Something like, yeah, these other parsers are usually way more delicate in what they accept. Well, you see how bad it gets if the time comes, I guess. But let's move back to files. So I'm going to say, well, at least an API, maybe HTML. These are in the service of getting you to the point where you have a file that you can just read, probably with pandas, and just go for it. Okay, so common things. A CSV file is, well, really just what it sounds like. It's something if you double click it, it will open up in your favorite spreadsheet program, but it's a really simple text-based thing. It is literally like this text, and I think I did this already. Yep. This is a CSV file. It's just strings are text and numbers are numbers, and they're separated by commas, and new line characters separate rows. That's it. Yeah, there is this convention that first row is column labels. Doesn't have to be true, but you could. And you, again, could if you really want to. There's a Python CSV library, but for us, probably just let pandas do it. You can say pandas.readCSV, hand it a file name. There's a bunch of other parameters there. In fact, I want you to imagine how many parameters you thought there would be to reading a CSV. And I bet this is more than you thought. Is there a header row or not? What's the data type arrangement here if they're not detected correctly? Are there dates? Do I want the dates to be strings, or do I want the dates to be turned into date objects? And if so, how? I bet there's a bunch of ways to figure that out. All the crazy crap that can be done, and not every spreadsheet program creates CSV files the same way, but, well, mostly it's fine. I probably wouldn't even bother with that. I would probably just go there. 3 columns became 3 data, 3 columns in the CSV file became 3 columns in my data frame, and hooray, right, done. Here I've said I would like the city name to be the index because that matches what I did back here somewhere when I created the thing manually, but as you like. Yeah, there's a lot more going on than just it. All CSVs are CSVs and they all work the same, but most of them work pretty similarly, and most of the time, most people, have done things in a reasonable enough way. You don't have to worry about all of these things, but I've had to do this. Gosh, there's an example somewhere in this course in my lecture notes where something looks like a number, so it gets turned into an integer when it gets read, but I think it's a string with many digits, and I want to treat it, I want it to be a string, so I had to override the type and say, no, don't, I know this looks like an integer, but don't, just keep it as a string. And you can say all of that stuff. The other thing that we're going to see in this course a bunch are JSON files, JavaScript object notation, which once again, very simple, very commonly understood, very well sort of documented. In fact, this is almost a complete documentation for JSON. Curly brackets are maps or dictionaries or objects, depending on what vocabulary your favorite programming language uses. Arrays or lists, square brackets, strings and numbers, and these special values. That's it. That's all of JSON, I think. Once again, there's a Python module for it. There's much more likely, for us at least, a pandas function for it. And this is just read the thing in. Or if I have this data frame, I can go too many things, to JSON in particular. And I can just do that. Wonder what I got. Sure, so that's the default JSON format, I guess, columnar. So I have these cities on a row labeled 0, 1, and 2. I have these populations on a row labeled, sure, that's sensible. That's probably also the default if I tried to read it back in. this is one where I might want to say something a little bit more here. Is it records, route lines? Oh, geez. Well, I know what I want. Actually, I want to say here. Oh, what am I? Super. Okay. So, yeah, great. Thanks. Thanks, help text. Okay. Yeah, this is how I'd usually do that. Let's get back to what that is. Yeah, CSV, the differences are pretty subtle. JSON, the differences, like that was a completely different file format I just created with a couple different arguments to the to_JSON method call. Which one do you want? Which one makes sense when you're reading it? Which one do you have? Like I said, this is the one I do the most often. It's new line delimited JSON or JSON lines or whatever you want to call it. But this is each line in the file is a valid JSON object is the rule. That's okay. There's a few more rules that are quite sensible. Yes, use UTF-8 encoding. That is a great idea. Sometimes I call it .jsonl or ndjson. Usually I just call it .json because I'm lazy and maybe I'm old-fashioned. But so this format is really nice because it's you can read it line by line. In a big data context, I could take 1 billion lines in text files and break them up into 1,000 different input files and read them all in parallel. And that's all really easy. And it's just a nice format to work with. It's nice to read. Like if you want to know, hey, what's going on with this record, it's all right there and very readable. So yeah, this is something you're going to get from me a lot. It's also the default thing for Spark when we get there. So just because there is this pandas read JSON function doesn't mean that any arbitrary JSON that you ever see is compatible with it. Most things you will actually find in real life if you can just figure out like how is the data oriented and what does it mean to be oriented, and maybe I could read all of this. Like if I went carefully enough through all these things, many things are possible, but not all. And I've made up this, okay, admittedly weird file format, but okay, it's not illegal. Pardon the sirens. This is one thing, when doing this course in the summer, recording lectures in this room does get steamy. And so I have to open the window, and now there's a fire truck or whatever. Fine. So sorry, I'm trying to think about fire trucks and give a lecture and type code at the same time. It's not going great. What I'm trying to do here is read this into a pandas data frame in some way as an example of just like, hey, this is a thing you can do. Okay, there we go. I now have a Python data structure, I hope. It is a list of these 3 dictionaries. Now I can start to deal with it. So we imagine I've gone through the whole process of, studying the pandas read JSON docs and realizing nothing in here will deal with this weird file format I just created specifically so I can do a demo. Now, what I've done here is that I've then constructed a data frame out of the thing that this function returns. What this function does is iterate through that data collection. It's a bunch of dictionaries. And deals with it. Why have I done it this way? Oh yeah, okay, that's fine. Good, that's fine past me. I'll accept this. Now, things that are going on here that you might not be comfortable with. You might not be comfortable with the yield keyword in Python, in which case, shame on whoever taught you Python. What's going on here is this is a sort of on-demand generation of these values. It's literally a generator function if you use yield in it. It's vaguely equivalent to this. So I'm appending this tuple. This function builds a list with all my data and puts it in memory. This one dynamically like generates them on demand. So there's less memory use in this version of the function than this version. But again, conceptually, same idea. This is, I've got another record, produce it, as opposed to I've got another record, put it at the end of my big data structure. Yeah, okay, so this is just, right, because I've created this incredibly stupid like dictionary with exactly one value where the key is the name of the city and the value is the list of two things that are population and area. So I've had to deconstruct that with a bunch of Python play in that line, and then I've got a triple. So again, like it's yielding a tuple of three things, or building a list of tuples of those things. Now I can create a data frame out of it. I've had to give the name of the columns because they're not here anywhere else. There we go. Again, I could have used either of these functions. They're both correct. Again, this one uses more memory. If I have 3 rows, I don't care. If I have 3 billion rows, I'm going to start to care about this. Yeah. If you've never encountered a generator function in Python before, they're a wonderful thing. In some sense, I'm injecting lazy evaluation into Python, if that is a term you know about. Again, it's a lazy generator. What other languages have different terms for this? It's kind of an async function, kind of. Anyway. Right, this point I just made, like if I'm doing this, like what I did in the slides was more like this. Is read not the method for a file to turn a file object into a string? Anyway, what I had done in the slides was I read the file into a string. I'd converted the string into a data structure, or the JSON string into a data structure. So that's already 2 copies of this thing in memory. And then if I'd used this function, I have a 3rd copy of the entire data set in memory, and then a 4th copy of the entire data set in memory. Again, if it's 3 rows, who cares? Fine, whatever. So by using a generator function, I skipped one of those. By handing the JSON.load a file handle instead of a string, I got rid of another one. So at least in this code, I only ever keep 2 full copies of the data set in memory in different formats. But I maybe need to think about that, especially if things get big. I can, if I so choose, what's my extra copy now? This. You know, if I return from a function, this local variable would get deleted, or I can explicitly delete it. So again, I don't know how often I've had to do this with JSON input. It's just JSON is usually predictable enough, at least in a data context. You do have to watch, right? Like there's this assumption here that the data is pretty predictable. where I have, you know, like a nice flat dictionary here with like pretty simple data types in the columns. A lot of APIs especially, and you certainly will find data formats that have this like deeply nested dictionary of dictionaries of dictionaries in here. And then just doing a read JSON is going to suck. And maybe it does make sense to disassemble it and then create a data frame. I definitely have had to do that now that I think about it. Okay, another common format that you might find yourself up against is XML. There are some pandas XML functions, read XML. I'm sure .2XML as well. XML, like, this has never successfully worked for me because people who create XML usually, well, maybe it could have and I was just ignorant, but usually people who create XML, it's usually more deeply nested and more freeform. If you don't know what XML is, I guess, think about HTML like this, except I get to choose. Like P means paragraph in HTML and H2 means level 2 heading. In XML, I can just choose whatever tags I want to represent my data. So I might have chosen something like this. This is perfectly legal, perfectly reasonable even. But I had the choice of like, here I put the city name in the body of the city tag and population and area were attributes. I didn't have to do it that way. There were other options. Did I not? Oh. I could have. No, okay, no, I'm going to keep it this way. I did it this way on purpose. So yeah, if you have a choice, I would almost never use XML as my file format. Sometimes you don't have a choice. It's just the thing you downloaded or was provided to you or whatever. And you've got to go. One of the ways you get XML is because it is really commonly used for a lot of cool stuff. If you have any kind of geographic data, like the thing that your smartwatch recorded when you went out on a run or whatever, it's probably going to be either it's going to be a GPX file or it's going to be something convertible to GPX because it has these things that are like latitude, longitude, time, and elevation, and a bunch of those. Well, that's exactly what I want if I want to record, you know, the run or the bike ride or the drive or whatever. Open document formats, like the things that LibreOffice produces, are zip files that contain XML. You can just unzip them, and then what's in there is like all the media, the images and stuff, and an XML document. SVG, you know, that you think of as something for images, if you know what it is, but yes, scalable vector graphics for this kind of thing. I have lines and circles and stuff. That is just an XML document. And in fact, like if I come up here, and if I look at the original, I can view source, Control U, and yeah, it's an XML document. And I could, if I really felt like it, treat this like data. You know, I could disassemble the paths and figure out where the corners are or something like that. I probably don't want to do that for this image, but I could. And again, I've seen students do projects where one of the things they did was like take this very structured SVG image and break it apart and get useful data out of it. And that sucked for them, but it was really cool. When it comes time to read XML, again, there's libraries that do it. If you have ever manipulated an HTML document from within inside JavaScript using document object model, well, you could use that with a Python syntax, or element tree. They're fine. Like they're both equally good. They're different ways to spell the same concepts. If you have data in XML, like SVG and HTML are usually pretty crazy freeform because they're representing a very human thing. If it's data, they're probably much more predictable and you can deal with it. So for this document that I have here, again, I've done a similar thing here where I have parsed the XML document into whatever it is. Well, it's a DOM document object. And then off we go. Where's my notebook? Okay, so let's do this. And then I need my, yeah, so I have XML data produced off screen here, but it's going to be something like, that. Okay. So again, this is a DOM document object. And if that means something to you, then great. It means the same thing as it does in JavaScript. You go to the reference docs and you find, oh, there's something called get elements by tag name, because all of the DOM methods were created by 1990s object-oriented programming fanatics. But this is some kind of iterable thing of elements. Yeah, there's 3 cities, and so what I have are 3 objects representing these 3 elements in the document. Great. And then where I'm going from here is create a data frame by applying this function to each one of them and getting the 3 values. So in each one of these, I've taken the population attribute, this thing, converted it to an integer, this thing converted to a float, and then taken the contents, so the child nodes or whatever is between the opening and closing tag. I know there's exactly one thing in there in my data format, so I can just index it out. I know it's text, and I know if it is text, I can say .data. That gives me a string, that string. So I can do that. So that, and then off we go, I think. Yeah. Is this the most beautiful way to do this? I don't know, probably not. You have your own call on that, but it worked. I handed Pandas a collection that was good enough to turn it into the thing. I didn't store too many extra copies of it. I hope it would be less if I did it this way. And hooray. If you like the element tree style, the method names are shorter, but you don't already know them, and you might already know them if you're a JavaScript programmer and you already know document object model. But off you go. I will say all of these things, the root here or the document element here, are all in memory. They're all in-memory data structures, which that's fine if you have like this 3-record thing that I'm using in the demo. If you reach for a Wikipedia data dump, for example, is this a great idea? I don't know, but it can be done. If you want English Wikipedia, or at least if you want all of it, that is it pages meta? No, maybe pages articles. Yeah, this one. Okay, so that's when it's bzip2 compressed, it's 2324 gigabytes. I bet if you uncompress that bzip2 compression on XML, it's going to be pretty good. That's going to be well over 100 gigabytes. And I'm in trouble. Okay, maybe it's not quite as big when you turn it into a data structure, but yeah, I'm in trouble here. I cannot apply this technique to that file because I'm going to run out of memory on that very first step. Again, I've done this. I have parsed XML files like that, and it sucks. Just as it does, if you need this, there is something called a streaming parser, which is, every time you get to an opening or closing element, hand it to me, and I'll figure out what to do with it. And one of the things I'm going to do with it when I'm done with it is dump its memory contents, because I don't need everything stored. This can be done. Again, if you have to do it, your life is going poorly, but you'll get there. or you can get there that way. And then, of course, there's just this infinite variety of other places your data might come from if you're a data scientist, or for the project in this course or whatever. I do not currently have a GoPro within arm's reach. There's one just over my shoulder in a box. It turns out when you take video with a GoPro, it's recording video, sure, and audio, yup. And there's actually a third track in that video, and it's the GoPro metadata track that records all of this stuff. Like, you know, the accelerometer XYZ 200 times per second, or the gyroscope, how much it's twisting 400 times per second, or the GPS data. Like, I don't know if you've ever looked at GPS data, but 18 times a second is way more frequent than anything else I've ever used. And for the 360 cameras, it's more. And you know, other action cameras, I don't know if other action cameras use the same metadata format or they something else, but they're going to have these sensors because they use them for image stabilization. So they probably dump it into the video file as well. It turns out a GoPro is a stunningly good data collection device. Yeah, they've changed the GPS the GPS has come and gone. Like there was, if you happen to have one generation of GoPro doesn't have a GPS. Oh, it's 12, and then it came back, but the format changed, and madness. Anyway, or like if you've ever worked with a web system, you know, at the co-op or whatever, it's pretty common to have like a whole bunch of containers or processes or whatever, all dumping the logs into something like Logstash. Again, there's many other log aggregators out there, which then would, the usual thing you do with Logstash is dump things into an Elasticsearch database. So there might be like every page read that's ever happened, as well as every, you know, login event and everything else somewhere, maybe, if you can get to it. Or there's some stream of data from some other sensors or whatever. This can be a challenge, right? Like, again, I think thinking of data I've used in the past, sometimes just like cracking it open is a non-trivial first step, but it's getting you past this, I guess. Okay. Okay, got a few minutes before I want to take a break here, so let's use those few minutes. YouTube videos can only premiere on the 15-minute boundary, like at 0 or 15 or 30 minutes after the hour. So I can't actually have an arbitrary break during a 2-hour lecture. I kind of have to do a 50-minute and then have the video premiere, which is what we're doing here. Once again, I have started my recording at a time that I'm going to be hangry, but all right. What am I talking about? Okay, sorry, extract, transform, load, which is the next slide deck here. This is something where like I question the need for this term just in and of itself. I don't need the term extract, transform, load. It doesn't add anything to my life, but people use it, and maybe thinking about the way you sort of have your data flow through your data pipeline and thinking of something happening in here as an extract, transform, load process. Maybe that helps you sort of put things in a better context just for yourself, or think of the right thing at the right time. Basically, having a stupid data format is something you want to fix. You don't want to, like if you have your data in the GoPro metadata format or whatever, in a, you know, a many gigabyte MP4 video, you want to get it out of there into some other format. Anything other than that would be easier to work with. So do that. Maybe it's going to be part of your data pipeline. Get it into a non-stupid, non-annoying format, and then move on. That's really what we're talking about here. Maybe the thing that you have or are about to do in exercise 1, maybe that's just an ETL task. It's taking the data from the format where you got it and turning it into the thing you actually need for whatever analysis you're doing next. So in exercise 1, I've had you do that in the sort of reverse order, because it's like, oh, do the simple little task to get used to pandas. oh, the data for that simple little task had to come from somewhere. It came from here. This is also another good pandas exercise. So you're basically repeating the ETL task that I did in order to prep exercise 1, first part. So there's 3 steps. Extract, transform, load. Extract is, I guess, what it sounds like. It's what I was talking about in the last slide deck. It's get the data out of wherever it lives into a place you can make some sense of it. Maybe that's a data frame. It's probably going to be a data frame, at least as we start here. So this is an extract step. Read it, figure it out. Fine. Transform, maybe transform is nothing. Maybe transform is something like exercise 1, where you're doing effectively a pivot or an unpivot, whichever way that is. Maybe it's a little bit of data cleaning at this step, which we'll talk about next. Maybe it's just a format change. Just like you're not going to do anything here. You're just going to change the format. So it's really easy to read in program number 2. Maybe what you have is you have data that's like, some sensor every minute. And that's just way too much data. You do not need that much detail. So you're going to just group by day and average. That will make a much, much smaller data file and way easier to deal with. And so that might be really nice. It might be nice to do that once and then move on. Maybe it's, I don't, there's the bad data, or the data I don't care about. This file has 27 columns. I only need 3 of them, that kind of thing. Again, depending on the context, maybe it's de-identification, which is stripping out personal identity kind of stuff. This is hard. Like de-identifying data in general, with data manipulation tools we have is really hard, but maybe. I think you should be very cautious. Like this is a fail fast scenario. And what I mean here, if you haven't seen assert, this is basically check to see if this returns true. If not, throw an exception. I want to know right now that my record makes sense, that the thing that I think is a length is positive, or that the name is not null, or whatever, just the things that I think are true. I want to know that they're true as part of this step. And then load, I would have called this save. I would have called it extract, transform, save, or store, but whatever. Somebody called it load. And I guess it's in the context of load it into the place you want it. I guess. Save it. I would have called that save, but nobody asked me. I didn't get a vote. And you want this to be nice. Okay, actually, before I move on, again, good spot for a break. So again, second video is probably linked over here. See you in 10 minutes or so.